So hello everyone, in this audio class we will discuss the 20 most important questions and their answers from the chapter Composition and Structure of Atmosphere. These questions will be very much important for your upcoming KVS and NVS Geography PGT interview. So let's get started with the question number 1. Why is the atmosphere considered essential for life on Earth? So the atmosphere is a mixture of gases, water vapor, dust particles surrounding the Earth. It is essential because it provides life supporting gases such as oxygen for humans, animals and carbon dioxide for plants. The atmosphere also acts as a protective blanket. It prevents extreme heating during day and excessive cooling during the night. Another important function is that the ozone layer absorbs harmful ultraviolet radiation from the sun. For example, if there were no atmosphere, the earth would become extremely hot during the day and extremely cold at night, similar to the moon. So the next question is, if atmosphere is mainly composed of gases, which gas is most abundant and why is it important? So nitrogen is the most abundant gas in the atmosphere, constituting about 78.08%. Although nitrogen is not directly used in respiration, it is essential for the plant growth because it forms an important component of proteins. So it also dilutes oxygen and prevents rapid combustion. For example, if the atmosphere contained only oxygen, forest fires would spread much more rapidly. Next question, why is oxygen important although it constitutes only about 21% of the atmosphere? So oxygen is essential for respiration in humans and animals. It is also necessary for combustion and oxidation processes. Despite being only 21% of atmosphere, it supports most biological activities on Earth. For example, when we burn fuel or breathe, oxygen is continuously being used. Next question, why is carbon dioxide called a meteorologically important gas? So carbon dioxide is transparent to incoming solar radiation but absorbs outgoing terrestrial radiation. Therefore, it traps heat in the atmosphere and produces greenhouse effect. It also helps maintain Earth's temperature suitable for life. For example, without carbon dioxide, Earth would become much colder and many living organisms would not survive. Next question, how does carbon dioxide contribute to climate change? So, an increase in carbon dioxide concentration increases the greenhouse effect. More terrestrial radiation is trapped, causing global warming. This may lead to melting glaciers, sea level rise and changes in weather patterns. For example, rapid industrialization and burning of fossil fuels have increased atmospheric carbon dioxide concentration. Next question, why is ozone called the protective shield of the Earth? So ozone is concentrated mainly in the stratosphere between 10 and 50 km. It absorbs harmful ultraviolet rays from the sun and prevents them from reaching the Earth's surface. Therefore, it protects living organisms from skin cancer and genetic damage. For example, without ozone, life on land would be severely affected by UV radiation. Next question, why is water vapor considered the most variable component of the atmosphere? So the amount of water vapor varies from place to place and from time to time. In warm tropical regions, it may reach about 4%, while in cold deserts and polar regions, it may be less than 1%. Water vapor decreases with altitude and from equator towards the pole. For example, Kolkata has much higher atmospheric moisture than Ladakh. Next question, how does water vapor influence weather and climate? So water vapor is the source of clouds, rainfall and all forms of precipitation. It also absorbs terrestrial radiation and acts like a blanket around the earth. Thus, it regulates temperature and weather conditions. For example, humid nights are generally warmer because water vapor traps heat. Next question, dust particles form only a tiny part of atmosphere. Why are they still important? So dust particles act as hygroscopic nuclei around which water vapor condenses. Without dust particles, cloud formation would be difficult. They also scatter sunlight and produce colorful sunrise and sunset effects. For example, cloud droplets usually form around microscopic dust particles. Next question, why are dust particles more concentrated in subtropical regions than in equatorial regions? So subtropical regions experience dry conditions and strong winds which lift fine particles into the atmosphere. Equatorial regions receive heavy rainfall which washes dust particles from the air. For example, the Sahara Desert contributes large amounts of dust to the atmosphere. Next question, why is troposphere called the most important layer of the atmosphere? So the troposphere is the lowest layer of atmosphere. All weather phenomena such as clouds, rainfall, storms and winds occur in this layer. It contains most of the atmospheric water vapor and dust particles. Therefore, it directly influences human life. For example, monsoon rainfall occurs entirely within the troposphere. Next question, why is the height of troposphere greater at equator than at the poles? So the equator receives maximum solar heating. Warm air expands and rises, making the troposphere thicker. Therefore, its height is about 18 km near the equator and only about 8 km near the poles. For example, strong convection currents in tropical regions increase the thickness of troposphere. Next question, why does temperature decrease with height in the troposphere? So the earth's surface is the main source of heat for the atmosphere. As altitude increases, the distance from the earth's surface increases. Therefore, temperature decreases upward. For example, mountain tops are cooler than nearby plains. Next question, what makes the stratosphere unique compared to the troposphere? So the stratosphere is stable and almost free from weather disturbances, and it contains the ozone layer. Temperature increases with altitude because ozone absorbs ultraviolet radiation. For example, commercial jet aircraft often fly in lower stratosphere because the air is more stable. Next question, why does temperature increase in the stratosphere? So ozone absorbs ultraviolet radiation from the sun. This absorption releases heat and causes temperature to rise with altitude. This absorption releases heat and causes temperature to rise with altitude. Therefore, stratosphere shows temperature inversion. For example, the upper stratosphere is warmer than the lower stratosphere. Next question, why is the mesosphere considered the coldest layer of the atmosphere? So in the mesosphere, temperature again decreases with altitude. Very little ozone is present to absorb solar radiation. As a result, temperature may fall to about minus 90 degrees Celsius. For example, many meteors burn up while passing through this layer. Next question, why is ionosphere important for communication? So ionosphere contains electrically charged particles called ions. These ions reflect radio waves back to the earth. Thus, long distance radio communication becomes possible. For example, radio broadcasting across continents depends on atmospheric reflection. Next question, what would happen if the ionosphere did not exist? So radio waves would escape in the space instead of returning to the earth. Long distance radio communication would become extremely difficult. Communication systems would be severely affected. For example, many international radio services depend on ionospheric reflection. Next question, why is very little known about the exosphere? So the exosphere is the outermost layer of atmosphere. The gases are extremely rarefied and gradually merge into the outer space. Because of its great height and very low density, detailed observations are difficult. For example, artificial satellites operate in the upper atmospheric region near the exosphere. Next question, and this is the last and final question. So how does the atmosphere maintain a balance necessary for life on the earth? So the atmosphere maintains life through the combined role of its gases, water vapor, dust particles and different layers. For example, oxygen supports respiration, carbon dioxide supports photosynthesis and regulates temperature, ozone protects life from ultraviolet radiation, water vapor regulates weather and temperature, dust particles help in cloud formation. Different atmospheric layers perform specialized functions such as weather formation, UV absorption and radio reflection. Therefore, the atmosphere acts as a life support system and protective shield for the earth. So, for example, the atmosphere works like a blanket around the earth, preventing it from becoming too hot during the day and too cold during the night. So thanks for listening. Keep listening for further audio classes. Thank you.